All right, so these are basic exponent rules. Again, just wiping the cobwebs out of your brain. They have the same base, you add their exponents. They're divided with the same base, you subtract the exponents. Separated by parentheses, you multiply. If it's ab to the x, you can distribute these exponents. A to the negative x gives me 1 over a to the x. A to the negative x on the denominator moves it up. All right, so just playing with it. So if you had something like this, you need to simplify, make no negative exponents, and have every variable appear only once. So I would just rewrite this so I can see what their powers are. You know that's to the 1/3. And so this is square root of x cubed. So you know that that's power over root. So now I can take the time to separate or subtract. So I want to keep positive exponents. So I'm going to take this, I'm just going to go slow so you can see what I'm doing. I'm going to take 3 minus 3/2, and I'm going to move this to the bottom. So I get 2 minus 1/3. So this gives me x to the 3/2. And then down here, I get y to the 5/3. And that's simplified as no negative exponents. All right, this here, I'm going to distribute this, multiplying these numbers. So I would get to the 4/3 power. Multiplying this, I'd get to the negative 2/3. So rewriting with positive exponents, I would just move this n term to the denominator. All right, so having ugly things like this, we'll want to simplify to one fraction, because you can see that this is 1 over y minus 1 over x minus y. So we've got fractions within a big fraction, complex fractions. So I'm going to multiply by the least common denominator. The least common denominator between the fractions would be xy. So you multiply numerator and denominator by xy. I know you've done this before, so just going over things you know. You want to cancel as you go, as you're distributing these. So multiplying this times this term gives me x. This times this term gives me subtract y. And then I'm not going to multiply this out. I'm just going to leave this the way it is. And then I notice, oh my goodness, the x minus y's cancel, so I'm left with just that. Many times not multiplying the denominator is the wise way to go. All right, let's look at this one. Another fraction going on in here. So I see that this is the same as saying x plus h all squared subtract 1 over x squared all over h. All right, so I'm multiplying by the least common denominator of all the fractions, so that would be these two. So that would be x squared times x plus h squared on the numerator and the denominator. Okay, canceling as you go, as you're distributing this out, I would get 1 over x, I'm sorry, not 1 over x squared. The 1 over x squared plus h's would cancel, so you would get just x squared, because you always want to get rid of the fractions, right? This term times this gives me just a x squared. These two multiplied, the x squareds cancel, so I get a subtract x plus h squared all over, and then do not multiply the denominator out. Leave it the way it is. All right, so these do not cancel, right? That would be really bad math to just go cancel these two, but I can multiply this out and see if something will simplify. So I get x squared subtract, and let's multiply this out. So x squared minus 2xh plus h squared. Carry this denominator along. And then distribute this negative through, so the x squareds cancel. So I get a positive 2h plus an h squared all over x squared h. Again, do not multiply the denominator out. I do see that there's an h in common. So if I take the time to factor the h out, then I can cancel, oops, what did I write there? I meant x plus h squared, right? Carrying that along. Then I can cancel the h's, so I finally get 2x plus h, x squared, x plus h all squared. That's my final answer. All right, let's look at this one here. So this is really similar to what we just did. So let's multiply top and bottom by the least common denominator, which is x times x plus h. All right, canceling as you go, as you distribute this through, I'll get x minus, and if I multiply these two terms, I'll get x plus h. Be careful of the parentheses so that this negative sign carries through. And then again, remember, do not multiply the denominator out. So then the x's cancel, so what I'm left with in the numerator is a negative h. And then I can cancel the h's. So I'm left with this. All right, so looking, let's move up to the top here for this one. So this one here, again, rewriting it, 1 over x squared minus, plus 1 over x, and this is 1 over x. So multiplying numerator and denominator by the least common denominator, which would be x squared. So that would give me 1 plus x all over x. Much nicer to look at. All right, this one here, multiplying numerator and denominator by x minus 1 times x plus 1, the least common denominator. So distributing that through in the numerator, I'll get, and canceling as I go, x minus 1 for the first term, subtract x times x plus 1 for the second term. On the denominator, I'll have x minus 1 and x plus 1 all squared. Oops, I forgot the 1 there. Okay, so if I multiply this numerator out to see if there's anything that cancels, there is not. Oops, x plus 1 all squared. So that just gives me a negative x squared plus an x minus a 2. And then that's not going to factor to anything to get us to do anything. So we'll just leave it just like that. All right, last one down here. This one's kind of a different one. So I've got fractional exponents. So this one here can be written as 1 over x to the 1/2. And so looking at that least common denominator, that's going to be x to the 1/2. So if I multiply numerator and denominator by x to the 1/2, that's going to give me a 1, and then multiplying these two, adding their exponents, I get x squared. Multiplying these two, adding their exponents, I get x to the 6/2, or cubed. Much nicer to look at.